Hello and good afternoon, CTS265, Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP route course, and this afternoon's video tutorial is going to be on another fantastic discovery activity, specifically Discovery Activity 17, where we're going to take a look at manipulating routing redistribution by using route maps. So we're going to take those prefix lists and those ACLs and that knowledge that we have already acquired from Discovery 16, and we're now going to apply it to Discovery 17, and we're going to incorporate route maps, and we're going to be using those route maps specifically to go ahead and set the metrics on some of the routes that we'll be redistributing. Okay, so let's go ahead and dive in here. You can see we have a dual redistribution scenario, right? A two-point redistribution scenario where router 1 is performing redistribution as well as router 4. So let's go ahead and jump onto router 1 here, and we'll go from user exec to privilege exec. I'm going to say show IP route. Let's see what we see right now. We have some OSPF routing information. We also have some EIGRP routing information. However, remember that this is all intra-domain or intra-area routing information. There's no external routing information here. So we're going to change that right now by going into global config, and I'm going to say router EIGRP 100, and let's say do show run section OSPF. We want to see what OSPF looks like. So the OSPF process ID is 10. So in order to redistribute the OSPF information into EIGRP, I would say redistribute, and then we want to put the protocol we're redistributing in. With OSPF, we need to have the process ID number, so that's going to be 10. And then we need to make sure we have the metrics in here. So we've got a bandwidth metric, and we'll say that this is simply 10,000. Then we have the delay metric, and we'll say that this is, we'll just put it at 10. The reliability will be 255. The bandwidth will say 1, and the MTU 1500, right? And that's it. So that is how we redistribute OSPF into EIGRP. So now let's go ahead and do the exact opposite. We're going to say router OSPF 10, and we want to redistribute. Again, the routing protocol that we're going to use is going to be EIGRP. The AS number is, we were just in there. It is, give me 1 second here. I'll scroll back up. I think it's 100. Yeah, router EIGRP 100. So we're redistributing EIGRP 100. Now, any word here that you see that we should include? Absolutely, the subnets keyword. Without the subnets keyword, I would only redistribute classful information. And in fact, if I hit enter right here, you can see we get a nice message that comes up and tells you only classful networks will be redistributed. This is not what we want. We want classful and, I'm sorry, I was going to type classless and classless, so we need that subnets keyword. So let me make sure do show run section OSPF. Let's make sure we only have one statement in there, which we should. And there it is, redistribute EIGRP 100 subnets. So now that we've done this on router 1, we're going to need to do the same thing on router 4, because again, router 4 is also a point of redistribution. So I come over here to router 4, and we're going to go from user exec to privilege exec into global config, and we'll walk through this a little faster. So just router EIGRP 100, we're going to redistribute OSPF 10 metric, and we'll say 10,000, 1, 2, 3. What did we use here? I think we used 10, 255, 1, 1500. So there we go, and then we're going to go in router OSPF 10, and we're going to say redistribute EIGRP 100 and subnets. Again, the subnets keyword is critical to make sure that we're redistributing classless and classful information. All right, so now let's do a little validation here. I've just redistributed from router 1 and from router 4 into the respective areas here. You can see over here we have 10.1, 10.1, 10.10, 10.11, 10.12, 10.13, 10.14, 5, 6, and 7. Over here it's 10.2. So the 10.1s would be coming from OSPF, and the 10.2s would be coming from EIGRP. So let me confirm on router 3, I should see OSPF, and we're going to include E2. So I should be seeing the 10.2 information here, which we do. And so this is great news. We also picked up a couple 172.16s. So we have successfully redistributed from EIGRP into OSPF, and there we can validate that right there. Now let me come over to router 2 right here. And these are the two 172.16s that we saw, the transit network segments. So now let me come to router 2, and I should see a substantially larger set of routing information that are going to be external. Whoops. And it's double typing there. EN. Huh. All right, let's see what we're doing here. Is there any way, let me manage devices here. Let me check real quick if I want to reload router 2. Let me reload the config on router 2 here. And let's watch this. So console clear, disconnecting. All right, it's booting up. And let's make sure that we can use router 2. All right, so it's up. It's a new adjacency, and it's still doing the same thing that it just did a second ago. All right, hold on one second here. Let's go back. Whoops. Come back over to Manage Devices. Let me clear the console. Clear the console connection for router 2. And we're hoping here. Yeah, it's giving me 2 characters for every 1 character I type. And so that's going to be a problem. We may have to continue on here. Yeah, so we'll continue on without router 2. And let me see what that's going to impact. So we're going to have an issue. We're not going to be able to validate the redistributed information that we're getting from router 2. Let me see here. So it won't let me exit out if I do Control-C. Yeah, that's interesting. It just keeps double typing the letters. All right, so we'll go ahead and we'll drive on here, and we will validate on the OSPF side. Okay, so we've done the redistribution. We're good to go there. So now what we're going to do is on router 1 and router 4, we're at step 3 here if you're following along. We're going to create a couple of access lists on both router 1 and router 4. So the first access list I'm going to create is going to be access list 10. I'm going to permit the 10.2.0.0.0.3.255. So 255, 255, 252.0 would be the subnet mask to match there for the 10.2s. And then I'm going to say access list 20. So it's a mutually exclusive access list here. I'm going to say permit 10.1.0.0, and this is going to be 0.0.7.255. So this would be a subnet mask of 255.255.248.0. So we have a slash 22 and a slash 21. Okay, so that's the access list that we're going to create on router 1. Now let's come over to router 4, and we'll do the same thing. So access list, whoops, access list 10, permit 10.2.0.0, 3.255, and then access list 20, permit 10.1, whoops, 10.1.0.0, 0.7.255. So again, the exact same access list on both of our redistribution points. So now what are we going to do? So now on router 1, we're going to go ahead and configure route maps that are going to match the information that's being redistributed. So on router 1, I'm going to say route map, and we're going to give this a name, simply a little arrow for into OSPF. And I'm going to say permit 10. Now, I'm going to match IP address, but this is where you need to be careful. If this was a prefix list, I would have to say prefix list. Since it's not, I'm just simply matching ACL 10, so I can put down the number of the ACL, because again, it was an it's not a named, it's a standard numbered ACL, not a standard named ACL. So I put the number here. So match IP address 10. All right, now I've got another statement here. It's going to be route map, and actually we've got another route map, so it's going to be into EIGRP. So we're going in the other direction. I'm going to say permit 10, and what are we going to do? We're going to match IP address 20 because that's the ACL number, and then I'm going to say set metric 1, 2, 3, 4, 10, 200. We'll say 5, 1500. All right, so let's go ahead and do a quick recap. Do show run and begin on route map. So let's take a look at our route map here and let's see what it says. So the first statement in this route map here is route map into OSPF. So this is a separate route map from this one here. So in this route map into OSPF, I'm saying that I just want to simply match IP address 10. Well, again, it's not an IP address, that's an ACL number, and the ACL we created was ACL 10. The second route map statement says into EIGRP, we're going to permit 10. So if I match on ACL 20, I'm going to set the metric, because again, this is going into EIGRP. So when I redistribute into EIGRP, I need to make sure that I set the metric. All right, now let's go to router 4, and we're going to get a little more practice here. We're going to do the exact same thing. So I'm going to say route map, and this is going to be into OSPF, permit 10. I'm going to match IP address 10. Then I'm going to create another route map. I'm going to say route map into EIGRP, permit 10, and I'm going to match IP address 20. And if I match IP address 20, I have to set the metric, right? Because again, this is EIGRP we're talking about, or the redistribution of external information from OSPF into EIGRP. So we need to make sure that we've got the metric set 1500. And now we have the same route map on both router 1 and router 4. So step 5, now we need to apply the route maps that we've created to the redistribution statements. Well, we're on router 4, so let's go ahead and knock it out right here. So I'm going to say router EIGRP 100, and what am I redistributing into EIGRP? I'm redistributing OSPF 10, process ID 10. Now that is not the ACL number there. That's the OSPF process ID from which I'm redistributing information. So redistribute OSPF 10, route map, and the route map is simply into EIGRP. So now the information being redistributed in is going to be subject to that route map, and that's going to set the that's going to set the metrics for us. So that's from OSPF into EIGRP. Let's say router OSPF 10, and now let's redistribute the EIGRP information from autonomous system 100. I want the subnet still, but I'm going to constrain what's allowed to be redistributed by saying route map, and again, this is into OSPF. All right, let's do the same thing on router 1. And I really like this activity because it's giving you the opportunity to repeat things that we're doing. So again, to reinforce the material we've been covering. So again, router EIGRP 100, I'm redistributing OSPF process ID 10, not ACL 10, process ID 10, and we're going to apply route map into into EIGRP. Let me make sure I've got that right. Yep, into EIGRP. So again, we're redistributing OSPF into EIGRP, and then I'm going to come back and say router OSPF 10, because here we're redistributing EIGRP autonomous system 100 information, including our subnets, into OSPF. However, we want to apply the route map into OSPF first. All right, so that's going to constrain the information we're allowed to see. So now let's go back over here to router 3. So remember, router 3 is in the OSPF area 0. So I come over here to router 3, and I'm going to say show IP route OSPF, and let's include E2. So now, what do you notice about the information that we're seeing compared to the information that we previously saw here on router 3 if I went back up? So remember, previously on router 3, we got the 172.16.20 and 21 OE2 information. However, now I'm only getting the 10.2 information because, again, what did our ACL match? So if I were to say show run include access list, and I apologize, let me get on the one of the redistributing routers here. Do show run include access list. So what did that access list allow? It allowed the 10.2.0.0 and then the 10.1.0.0. So access list 10, I did not mean to switch screens there. So again, we're redistributing from EIGRP into OSPF. So do show run section OSPF. When we're redistributing that EIGRP information, the route map that we're using is into OSPF. And what is the route map into OSPF showing me? I am matching IP address 10. So I'm matching ACL 10. And if we look up here, ACL 10 says permit 10.2.0.0 if it's a /22, right? So 10.2.0.0/22, that's going to be allowed. If we come over here to router 3, we can see that we did match the first 22 bits, right? So I've got 10.2.0.0/24, and we're matching all of this information here because 0, 1, 2, and 3, if I was to summarize these, the 0 and the 1 would be a /23, the 2 and the 3 would be a /23, and those two /23s are a /22. Therefore, because of the access list that is referenced by the route map, on router 3 we're only going to see these 4 routes because these are the only 4 routes that meet access list 10's ACL statement. Okay? All right. Now, the second part of this activity would be to take a look on router 2, who, let's see if he wants to cooperate here. He's still not cooperating. For whatever reason, it is Control C. Yeah, for whatever reason, it's still printing 2 characters for every 1 character we have here. And let's take a look. So step 8, we want to change the administrative distance for external EIGRP routes to 100 on router 1. And so what's going to happen when we apply this distance EIGRP command? Excuse me. The local default values for internal and external routes that are being redistributed are going to change. So we're going to keep 90 for internal, but we're going to change the external to 100. So let's jump onto router 1 here. And we're going to say router EIGRP 100. And so you can see we've got a distance command. Now, if I had, I could set the administrative distance right there, but we're not going to do it there. We're going to do it here. So the distance is EIGRP because I want to set the distance for internal routes. We'll leave it at 90. And I want to set the distance for external routing information. Now, why would I want to set the distance for external routing information to 100? If we think about this, and I've got this sinking feeling that we're going to go... we're not. Okay, good. So we're going to do all this on router 1. So before I do that, let me say Control U, do show IP route. So you can see right now, for all of the 10.1s here, I'm learning them via which routing protocol? Via OSPF. And these are intra-area OSPF routes, right? Because router 1, as we can see here, has an interface into OSPF area 0. So all of the 10.1 routing information is being learned via OSPF. And you can see my administrative distance here is 110. So what I'm doing with this command, which is distance EIGRP 100, what I'm saying here is that for EIGRP information that I'm receiving, that the administrative distance for external information is going to get lowered to 100. So what do you think the impact of that's going to be? Well, let's check it out. Do show IP route. Sorry about that. I did it. Had to wait for the. We changed the administrative distance. I did it just a second too early there. Do show IP route. Let's check it out now. And it's pretty nice, right? I did it super fast right here, and you can see it was still OSPF. But now, how am I learning all those 10.1 addresses? Exactly. I'm learning it via external EIGRP because I've changed the administrative distance. If I were to rerun that command and say 110, what do you think is going to happen now? So I've changed the external EIGRP administrative distance to 110, so it matches OSPF. I was waiting there for the adjacency message. Now when I say do show IP route, we're still learning that external EIGRP information. What if I were to set it to 111? And let's wait for the adjacency to go down and come up. Give it a second here. And come on. All right, there we go. Configuration change. There's my second message. So now when I say do show IP route, it's the OSPF routes that went out. So again, the administrative distance here is 110, which is less than 111, so I install the intra-area routing information that I'm learning via OSPF. All right, so this is going to wrap up the Discovery Activity 17, where we got to take a look at using the ACLs along with the route map construct. We did not do prefix lists. However, if we did, it would be used in very much the same way, except we would be able to consolidate maybe a little bit better with the prefix list. All right, this wraps up Discovery 17. I will see you all on Monday.